There's a problem with using traditional REST APIs. We always get the same server response for a given endpoint. This lack of flexibility can lead to two equally annoying issues. The first, overfetching of data, when we get a huge response but only need a small piece of it. Our second problem, underfetching, when we perform the first call only to receive a small piece of what we needed. We would have to chain multiple API calls together to assemble all the data we need. Wouldn't it be great if instead we could shape the response we get with the request that we make and fetch only what we need when we need it? So this will solve the underfetching problem as well as the overfetching problem. Fortunately, this is possible with GraphQL, a modern way to build and query APIs. In this course, we will be creating a Vue and GraphQL app together to gain the confidence of using this powerful modern tool. In a nutshell, GraphQL is a syntax that describes how to ask for data, and it's generally used to load data from the server. One of the core features and the biggest benefit of GraphQL is that you get only the data that you asked for. The main difference between REST and GraphQL lies in where the shape of the API call response is defined. With REST, the shape is defined on the server. With GraphQL, this is done on client side. This allows us to make a single request to fetch all the required information and nothing else. To understand this difference better, let's look at an example where we'll compare fetching data from GitHub using both REST and GraphQL APIs. Imagine that we want to fetch a list of repositories of a certain user, and we will check what programming languages are used in those repos. With a REST API, first we would perform a call for users, username, repos, which would get us a list of repositories. But what if we wanted to know the programming languages used in each repo? Looking at the data, we only have the languages URL links to retrieve the languages with. This means that we need to take another step and iterate over the repositories list first, fetching languages for each one using that language's URL. So how is this different from GraphQL? Using it, we send a query string that specifies the fields that we want to fetch. The string is interpreted on the server, which returns JSON back to the client. Let's see what this looks like in the code. We are now looking at an explorer called GraphQL with an I. It lets you examine the GraphQL API. As you can see, with only one request, we fetched everything we needed without any additional overfetched data. An added benefit of GraphQL is that it uses a strong type system to describe all the possible data that you can fetch from the GraphQL server. This set of types is known as a GraphQL schema and can be examined in a UI like GraphQL. Strong types make GraphQL less error-prone, can be validated during compile time, and we can use IDE tools for validation and autocompletion. Now that we are starting to understand how GraphQL provides a unique ability to query our data, how do we work with it on the front end? We could use POST requests, but it's more convenient to use one of the GraphQL clients. In this course, we will be focusing on Apollo client and its Vue integration, which is called Vue Apollo. We'll learn how to fetch and change data on the server, how to work with real-time subscriptions, and even learn how to use a built-in Apollo client cache to replace your local state management tool like Vuex. To get the most out of this course, you'll need a solid understanding of Vue itself and the Vue CLI, as well as fundamental understanding of the Composition API. So if you're ready to start feeling confident, plugging GraphQL into your Vue apps, I'll see you in the next lesson. Before making our first GraphQL query from a Vue application, it's helpful to check out the GraphQL playground so we can learn how to write simple queries there first. This course will focus on the client side of GraphQL, but you still need a GraphQL server to work through the lessons. We have prepared a GraphQL server repository for this purpose. You can just simply clone the repository and then install the dependencies by running npm install. After this, you'll run the Apollo script. As a result, you should have a GraphQL server running on localhost port 4000/GraphQL. Let's click the Docs tab on the right and explore a bit. You can see that the first query in the list is all books, which returns an array of books. Here you can see possible fields you can get when fetching a list of books. With this in mind, let's write our first query in the playground, where we get the ID of our books like so. The query name all books here is optional and can be anything. However, it's highly recommended to give your queries names, since this will help with the debugging of them later. Now that our query is ready, let's click on the Run button and check the response. So far, so good. We got an array full of one object for each book, containing its ID. Now let's add more fields to the query to get more info about these books. You can see how the response structure has changed to reflect the request changes. Now that we have a bit of practice writing queries in the playground, let's start implementing them on the front-end side and add the very first query to our Vue application. To follow along with the lesson, you would need a Vue app. You can create a brand new Vue app using Vite. Before we get started, we need to install some packages from the terminal. First, we need the GraphQL package. This is the JavaScript reference implementation for the GraphQL query language. Next, we need a utility package called GraphQL tag, a template literal that will help us to parse our GraphQL query strings. This package also contains a Webpack loader, but we will take a look at that later. And then we need Apollo client. Apollo client for GraphQL that will help us send requests to the GraphQL server, track loading state, and cache the results. Lastly, we need Vue Apollo Composable, a Vue integration for Apollo client that uses the Vue Composition API. Now that we're done installing the packages, let's head over to the main.js file. We are going to create an Apollo client instance here. This instance will serve to manage both local and remote data in our application. With it, we will be able to fetch data from the GraphQL API, change the data on the server, and update the local cache with the new data. We have to import this Apollo client class. Next, we need to configure a link for the Apollo client instance. With the use of create HTTP link, we create a link to the GraphQL API. In our case, the server is running on localhost 4000/GraphQL. And we need to import this create HTTP link function we're using. Aside from HTTP link, our Apollo client instance needs a cache. We'll create the cache up here using the in-memory cache class. Cache is the Apollo client cache, where all the query data will be stored. We will take a look deeper into this later. Since we're using the in-memory cache class, we have to import it. Let's clean this up a bit. Now we're ready to use our new Apollo client instance to perform a query. First, we have to create a constant to store the query string. We can just copy our query from the playground and put it here. Since we're using GraphQL tag to parse a query string, we have to import it. With this query string constant, we can call the query method on the Apollo client instance to query all the books. And finally, log the result to the browser console. Here, we are making a simple GraphQL query like we would call a REST API. We make a network request to our GraphQL server, and when it's resolved, we show the response in the browser console. We should see a result with 7 books in the list. With Apollo client.query, you can perform GraphQL calls from outside Vue components. You might need this, for example, if you decide to keep a local store in Vuex. But what if we want to make an in-component call and connect its results directly with the Vue reactive properties? We'll see how to do that next. Since we won't need this anymore, let's comment it out. In the main.js file, we need to import default Apollo client from Vue Apollo. This is a Vue Apollo helper required for providing the Apollo client instance to the Vue application. Next, we need to import the h function and the provide method from Vue. To add Apollo to our Vue app, we have to first refactor this create app call. Then, we have to render the app component using a render function. This refactor doesn't change any behavior, but now we can create a setup function and inject the Apollo client instance to the Vue application. Now we are ready to call a query from the Vue component. Let's copy our query constant to the app.vue component. Since the query string is now in this file, we have to import GraphQL tag for this to work. We'll be using the useQuery function to make the request. We'll make the request in the setup function. This is a component property added in Vue 3. It's executed before the component is created, once the props are resolved, and serves as the entry point for composables. useQuery is one of such composables exposed by the Vue Apollo library. Under the hood, it performs a GraphQL query, handles the loading and error state, and returns them back to the component. We have to return the result to make it available to the template. Before we move on to the template, let's first log the results variable to the console and see what it looks like. As you can see, what got returned is a ref, which means it's a reactive object with the value property. All the books are stored inside this value property. Now, let's render the result in the template. We'll use v-for to loop through the result.allBooks array. We are using each book ID as the key. And finally, render the book title. We don't have to use result.value here because the reactive variable is automatically unwrapped when it's used in the template. Now, we should be seeing all the book titles on the page. In this lesson, we learned how to make simple queries to fetch data from the GraphQL API and how to work with this data in Vue components. In the next few lessons, we will work on setting up some tools to improve your developer experience. And then we come back to learn more advanced GraphQL queries. See you there. Now that we've made progress getting GraphQL up and running, it's a good time to pause to make some optimizations for our developer experience before we go deeper. Creating a string-based constant for every single query is not very convenient. For example, we don't have proper autocomplete. Additionally, having multiple string queries stored in the same file will make it look crowded, and it's difficult to reuse these queries down the road. As a solution, we are going to put our queries in external GQL files that can be imported into the component directly. First, we need to install a rollup plugin. Since the rollup plugin is compatible with Vite, we can use it as a Vite plugin. To use this new plugin, we have to go to vite.config.js, import the plugin, and then use it inside the plugins array. And we are done setting up for Vite. Now, for the UCLI, we don't have to install any additional plugin. All we have to do is to create a view.config.js file and then add the proper Webpack configuration there. This GraphQL loader plugin comes from the GraphQL tag package we installed in the previous lesson. That's it for the UCLI setup. Now, I'll switch back to using the original Vite app for the rest of the lesson. Our app is now capable of recognizing import files with the GQL extension. Now we can create a new folder called GraphQL and add a file inside called allbooks.query.gql. This is where we will put our allbooks query. So let's go back to the app component and copy the query from the string, and then go back to the query file and put it here. Now, in the component, we can remove importing GQL and the query constant, and instead import the query directly. It's a useful naming convention to have the type of the operation as the first extension. In this case, it's the query type operation, but we'll learn to use two other operation types, mutation and subscription, in a future lesson. For the second extension, we're using .gql here, but alternatively, we can also use .graphql. Let's make sure that it's getting the data from the server successfully. With this knowledge, we can move all the queries to dedicated .gql files so they can easily be found in the project structure. So far, our code looks very plain without any code highlighting. Also, we don't have linting and autocomplete in GraphQL files. Fortunately, there is a simple fix by using the GraphQL schema and IDE plugin. We can use the plugin to pull the schema from the server. Then the plugin will be able to validate our GraphQL queries against the schema to enable linting and autocomplete. We are going to install the Apollo GraphQL plugin for VS Code. And for WebStorm users, you can install the JS GraphQL plugin, which has been renamed to just GraphQL. As soon as the extension is installed, you should see that your GraphQL code is now highlighted. We didn't have to connect the plugin to the GraphQL schema to get this syntax highlighting, but to get the other more powerful features such as linting and autocomplete, we have to connect the plugin to our GraphQL schema using a config file. We are going to add the config file to the root of the project, name it apollo.config.js, and drop this config code in the new file. You can get this code from the text version of this video. And for those of you who are using WebStorm, the config file has to be named .graphqlconfig, and the config code is also a bit different, but you can get this snippet from the text version as well. After restarting your IDE, you should now have GraphQL file validation enabled, which is just another term for linting and autocomplete. As a final step to improve our developer experience, we can install Apollo DevTools, which is currently available for Chrome and Firefox. After the installation, when running an application in the browser, we should have one more tab in the browser DevTools. Here we have a GraphQL Playground tab, where we can check the schema and run queries. Click on the Queries tab. We can see all the queries that have been executed in our current view app. We have executed one query so far. We have not executed any mutations, but if we did, they would appear under the Mutations tab. Lastly, there's a Cache tab. The cache is very important when we work with a poll client because by default, the result of every query is cached. With these tools, we now have a developer-friendly environment that helps us to prevent errors with wrong query fields and makes the debugging process easier. We are now ready to return to developing with GraphQL in a smoother way. See you in the next lesson. Welcome back. So far in this course, we have been fetching the full list of books. This was fine because our list was really short. But what if we had 1,000 books? I needed to search for a certain one. For more complex queries like that, we can take advantage of GraphQL's search parameter. Before we integrate this feature into our actual app, let's head back to the GraphQL playground to practice. We'll utilize the search parameter on the all books query. In this example, we are using a hard-coded value on our query. To be able to pass a dynamic value to the GraphQL query, we can use GraphQL variables. First, let's declare the variables our query can accept. Variables must be prefixed with a $sign, and we need to define a type for them. In our case, we are searching for book titles, so our search variable is definitely a string. Now, we can pass the $search variable to the search argument. We can also check what is accepted as a search parameter. Choose the all books query, and we can see that it accepts a parameter called search, and it has to be a string. To test this query with actual data for the search variable, we can use the Query Variables tab here. This has an object that contains the search variable, and we'll use a random string as test data. As you can see, now our results are only books whose titles contain the string the. Now that we've gotten this practice in the playground, let's make use of the search functionality in our View application. To add the search ability, we'll first need to modify the all books query in our View application to reflect those changes we made in the playground. Now, in the app.view component, let's pass a variable to the useQuery composable. To make a quick check if it works, first we're going to pass a hard-coded string. Now, when we run our app, we'll see that the render result has changed. So far, so good. But we want to make this interactive so that we can make real-time searches for anything a user types into a search input. So let's go ahead and add a new input field and bind that field to a new reactive property. We'll create this search term variable next. First, import ref, and then create the search term variable as a ref, and return it so that the template can access it. Now, instead of that hard-coded string variable, let's replace it with a search term .value. We're almost there, but right now this is still not going to work. To make the query change based upon the input variable, we need our search argument to be a function that returns an object as the variable. Now, whenever we type, the new query is sent to the GraphQL API, returning the list filtered according to our search term. In real-life applications, user interfaces actually display some kind of loading state when an API request is still in progress. It's common to create a loading flag, setting it to true when the query starts and false whenever it's resolved. In an Apollo client, this is done automatically for us. The only thing we need to do is check the loading state by returning it from the useQuery composable. Now, we can modify our template to display a loading message conditionally whenever a query is in progress and otherwise render the query's results. In order to test this, we have to set the network connection to slow 3G so that the response is slow enough for us to see the loading indicator. As we type each character, you can see the loading indicator while the query is being processed. You might have noticed that when we type the same search term for the second time, loading is not displayed. This is because after we fire the same query with the same variable once, the result is actually stored in the Apollo cache. And when the same query is sent again later on, it will retrieve the data straight from the Apollo cache. So there is no loading state in this case. You can always check cached results in the Apollo browser DevTools. Now that we're done testing the loading indicator, let's change the network speed. Sometimes our queries return an error. It might be a network error, a wrong query name, or asking for fields that don't exist in the schema, a wrong variable type. On the front-end side, we need to handle these errors gracefully and show a proper warning to the user. In the case of Apollo client and View Apollo, an error property is returned from the useQuery composable, similar to loading. Let's make it available to the template. And then we can render an error message conditionally. In order to test this error message, we have to create an error on purpose. Let's modify the query to return an attribute that doesn't exist. This will cause a failing request. And if we get rid of this invalid attribute, the error will go away. In this lesson, we've mastered our knowledge of GraphQL queries. Now, we know how to work with variables, handle loading and error states, and how the query results are stored in the Apollo cache. In the next lesson, we will continue with some more advanced cases of GraphQL queries. See you there! Welcome back. In the previous lesson, we created a type-ahead search by passing a parameter to the GraphQL query. However, it has a few flaws, which we will fix in this lesson using some advanced options of Apollo query. Let's dive right in. With our current implementation, we send a query on every new typed character. But imagine if we decided to type a really long book title. This can result in many unnecessary queries while we only need one. To limit the number of network requests, we can use a method called debouncing, where we are going to limit the rate at which the query is fired. For example, we can set the delay to half a second. Then, the user starts typing, and when the user stops typing, the timer will start counting down. If the user doesn't type anything else within the countdown, the request will be fired and only once. Luckily with Apollo, we don't need any external libraries to implement debouncing for our queries. We can pass a delay to the useQuery function as a property of the third argument. In here, we can use the debounce option and set the delay in milliseconds, so 500 means half of a second. With this simple option, we only send out the query when the user stops typing. At the time of this recording, the Vue Apollo composable package is still in alpha. There's a bug related to debounce in version 4 alpha 16. It may have been fixed by the time you're watching this video. But in case that debounce still doesn't work in the most recent version, you can revert the version back to an older version where debounce is still working. First, uninstall the Vue Apollo composable from your project. Now, we can install the Alpha 12 version, but we have to use yarn to install it because this version does not work well with npm install. After the installation, debounce should be working properly. Another best practice when it comes to search is to start searching only after the search term has at least 2 or 3 characters. This means that the query will only be fired when the condition returns true. Surprisingly, when adding this condition, our application broke. This happened because we tried to access a property, all books, of the query result, but the query is not fired, so result is still undefined. We will handle this properly in a few minutes. For now, we can change a condition on the template to only display the list when we have a result. Now the page will be empty until we type 3 characters at the very least. As we just saw, sometimes it can be handy to have a default value for the query result to prevent cases where it's undefined. Also, it would be nice to extract a nested property of it. We don't really need a result. We need only all books to render in our template. To handle such cases, we can use Vue Apollo's useResult composable. We are going to use this function to clean up the response data. Let's retrieve the allBooks property and save it into the newBooks constant. The first argument here is the result that we got back from the query. The second one is a default value for books. In case that there is no result, we want it to be an empty array. So when the query is not called, we will be iterating over an empty list. Finally, the third argument is a function that defines what data we want to extract from the query response. In our case, we want to get the all books array. After the recording of this lesson, useResult has been deprecated. The recommended way to replace useResult is to use a computed. Retrieve all books directly from result.value and return it within the callback. We need the question mark after result.value so that this whole thing returns undefined if for some reason result.value is not defined. And then we need this double question mark. It will make sure that if result.value or all books is undefined, this array will be returned as a default value. Now we just need to remove result and return books instead. Also, we need to make changes to the components template. Now that the books data is an empty array by default, we can change this back to just VLs, and then change results.allBooks to books, and we're done. In this lesson, we learned a few techniques we can use to craft our queries. Now we know how to add debouncing to limit the query calls rate, and we learned how to enable queries only when a certain condition is met. Finally, we did a nice small refactoring to the existing code by picking all books from the query result and providing a default value for it. In the next lesson, we are going to start modifying data we store on the server. We will be learning GraphQL mutations. See you there. Welcome back. So far in our example app, we have only been fetching data from our GraphQL API endpoint. In this lesson, we'll learn how to modify that data on our server by using GraphQL. In a REST API, we typically use GET requests to fetch data, and we use POST, PUT, PATCH, and UPDATE to change data on the server. But with GraphQL, we simply just use query to fetch data from the server and use mutation to change data on the server. Before we start making any changes in our front-end Vue app, let's learn how to update a book's data in our GraphQL playground. Let's go ahead and open the right Docs panel and look for the Update Book mutation there. First of all, we can see that our mutation accepts an argument of Update Book input type, and this argument is required. That's why it has an exclamation mark next to it. This means that if we don't pass in this argument, the mutation will fail. In the type details section, we can see the return type of the mutation, which is what the request actually returns. In our case, we will have there a modified book. Let's learn more about update book input parameter now. It expects us to always pass in the ID of the book. It has an exclamation mark, meaning it's a required field. And we can optionally add any field from the book type. The fields we pass in will get updated. Let's write our first mutation. Imagine that the Guardian's book became super popular and we want to set its rating to 5. Now, let's write the mutation. We will be using the update book mutation with the input parameter. First, we'll need to know the ID of the book we want to modify, passing this ID in along with a new rating. We want the response of this mutation to include the ID, title, and rating of the updated book. Let's run it and then check the all books query again to make sure it's updated. Success! The book's rating has been changed to 5. Now that we've learned the basics of how to work with mutations, let's modify our application interface to be able to edit books from there. Let's add a new Vue component to edit a book's rating. We are going to call it Edit Rating. I'm going to paste in some code. You can get this snippet from the text version of this video. This component should take a current book rating and book ID as props. It will render an input field so that we can edit this value and close the form upon pressing the Escape or Enter button. When the Enter key is pressed, it will trigger the update rating function, which is defined down here. In this section, we will also print the new value in the console when pressing Enter. This will be replaced with the mutation call in the next step. After we press the Enter or the Escape button, our component will emit a close form event. We will be listening to this event in the parent component app.view, and we will close the form after it's fired. We are not currently making any use of the book ID prop, but we will need it in the next step to call the update book mutation. Now, we need to modify the app.view so that we can edit the books from there. We will create a new property called active book. We have to make active book available to the template and add edit buttons to the books in the list. When the edit button is clicked, we will set this book as the active book. Let's also render the rating next to the title. When a book is under editing, we will hide the list and display only the edit rating component instead. Now, let's import the edit rating component and make it available to the current component. We are going to render the edit rating component here conditionally. We want to render this part only if active book has been set with a book. And we are going to render this part only when active book is null. But first, we have to wrap this in a template tag. And now, we can use VLs in here. Let's check out our new UI in the browser. Click on the Edit Rating button and we'll see the input field. If we change this rating to 4 and hit Enter, we can see that it didn't change anything. To make this functional, we have to replace the console log with an actual mutation request. Let's first create the update book mutation. This is the same mutation that we used in the playground. As you can see, we are passing two variables to our mutation. The first is a book ID, and the second is a new book rating. Where did these variable types come from? When in doubt, we can always check the schema in our GraphQL playground. As you can see here, the update book mutation accepts a parameter of update book input type. We can see that it has 6 fields: a required ID field of the type ID and 5 optional fields. Rating has a type of float. Now we know which types we should be using for these variables in the mutation. Now, let's go ahead and import our update book mutation into the edit rating component, along with the View Apollo's useMutation composable. useMutation is a composition function similar to the use query we used previously. Let's start writing our mutation. We'll extract the mutate function from the useMutation composable. It takes a mutation and options as parameters. It's always good practice to use a function returning object for the second parameter of the useMutation. This way, you ensure that any changes to a component's reactive data will be applied to the mutation's variables. The option we need for our update book mutation is the variables option. We'll set the ID using the book ID prop and set the rating using the ref value. But rating has to be parsed as a number because it comes straight from the input field as a string. We'll use this mutate function to send a mutation to the server. And that's it. Now, when we edit the rating and press Enter, the form closes, and after some time, we can see the rating updates. Our user interface is far from perfect now. The form is closing before the request is resolved. There is no loading state and no error handling. We will improve this in the next part of the lesson. But for now, let's focus on what is happening under the hood and why the rating was updated in the UI. If we check the Network tab, we can find the mutation call there. This response contains a book ID and updated book data. Apollo client considers ID as an entity key. When we update the book, Apollo is smart enough to merge all the new data to the book with the same ID in the cache. When the cache is updated, all the GraphQL queries that are related to this updated data will receive the new result. It's like a subscription. That's why in our app.view component, the books were automatically recalculated and re-rendered on the page. However, if we remove the ID from the mutation result, there will be no cache update. So if we change this 4 to 5, we are still seeing 4 in here. As you can see, the mutation is sent and it's returning a response. But the cache is not updating because Apollo Client does not recognize what book was updated. If we refresh this page, we will see the updated value because this came straight from the server. Let's go ahead and return ID back to the mutation and improve our edit rating component logic a little bit. When looking at the update rating method, we can notice two issues. First, it doesn't do much except the mutation call and emitting an event. Secondly, the close form event is fired immediately, but in practice, it should wait until the mutation is resolved. To fix the first issue, we will alias mutate to update rating. We are not going to need this update rating function anymore. So when the template is calling update rating here, it's actually calling the mutate function under the hood. To fix the second problem, we'll use the undone hook. In this callback here, we can specify any logic we want to be executed after the mutation has returned a response. In our particular case, we want to call close form from here. Now the form waits to close until we have a response from our GraphQL API. It would be really nice to also somehow indicate that there is a mutation in progress. Let's go ahead and display a text updating right below the input field and disable the input when we are waiting for the mutation response. First, we need to extract loading from the composable and then return it from the setup function. Now, let's add a loading indicator in the template, and we'll do that conditionally if loading is true. Now let's test this new loading indicator in the browser. Change the number here and hit enter. We didn't see the loading indicator because the network response was too fast. We have to set the speed here to slow it down in order to see the actual loading. Let's try to update the rating again, and this time we can see the loading indicator. Don't forget to change the speed back to normal. The last but very important change is handling an error. Similarly to loading, useMutation returns an error property. After returning it from the setup, we can use this property to render an error message for the user. And we're also going to use the if here. Now, in the update book mutation, let's change the mutation name to trigger an error. After editing rating and pressing enter, we will be able to see an error message. Let's change the name back to update book. If we put the query and the mutation side by side, we can see that they share the same fields. Is there any way to reuse the same set of fields across different queries? The answer is yes, and it's called GraphQL fragments. Let's go ahead and create a new file called book.fragment.gql and add a new fragment to it. We want a fragment called book fragment, and it's based on the book type. And this fragment will include ID, title, and rating. Here, book fragment is a fragment name. You can choose whatever name you prefer. Book is the GraphQL type that this fragment is based on. And your fragment can only include fields that exist on this type. Now, let's make use of this fragment. In the all books query, we'll first import the new fragment. And now, we can replace all these fields with the book fragment using the spread operator. Let's do the same for the mutation. Import it here and use it here. And we're done. Now, if we decide to change the set of fields we're working with, we can make these changes on the fragment, and they will apply to both the query and the mutation. In this lesson, we have learned how to update data on our GraphQL server using mutations. But what if we want to add or delete a book? Apollo won't have an ID to implement cache updates, so our UI won't reflect any changes. We will learn how to handle such cases with manual cache updates in our next lesson. See you there! Hi everyone, I'm here with Natalia Tepluhina, Vue core team member and most importantly, mastermind behind the GraphQL course here in Vue Mastery, we asked you to provide some questions of things that you want to learn specifically about Apollo and GraphQL in Vue. And I'm here with her to answer some of those questions. Hi, Natalia.
Hi, Marina.
You want to get right into it?
Of course.
Awesome. So let's go right into it. First question. Welcome back. In the previous lesson, we learned how to change the data on GraphQL server with mutations and how they are able to automatically update the Apollo cache. Unfortunately, automatic update is not always the case. This works when we have an existing entity. In our case, it's a book, and we update some of the properties of it. But what happens if we want to create a new entity and add it to the list? How then do we handle Apollo cache changes and UI updates? We will answer all of these questions in this lesson. Before we start adding any new code to our Vue application, let's first shape a mutation to add a new book in our GraphQL playground. As we can see here, the add book mutation expects a book input type. We have to provide book title, author, and a year as a bare minimum. You can see these fields are required because they have a little exclamation mark on them. Now we don't need to provide any ID. The unique identifier will be generated for us on the server. This mutation will return us a newly created book. Let's write a mutation in the playground and see what is returned in the response. The add mutation accepts an input parameter. For simplicity, we'll hard-code the input data here. We only need the 3 required fields. Let's also make it respond with some data from the new book. We can run this mutation. Now, if we run all books query again, we will see a new book in the list. Now that we have nicely shaped a mutation, we can move on to writing a component to call this mutation. Back in our project, let's create a new file, addbook.vue, in the components folder. You can get this code from the text version of the lesson. We want this new component to be a form containing 5 fields. We won't care about form validation much in this lesson, but we will make title, year, and author required fields to match the required variables in the addbook GraphQL mutation. Also, we want to have 2 buttons. One will submit and close the form, and the second one is a cancel button just to close the form. As you can see, we already have an event to emit when we want to cancel the book form. Now, in the script part of the component, let's add a new book reactive object and a placeholder method addBook. For now, we want to just log the new book in the browser console and emit the event to close the form. We declare that the component will emit an event to close the form. In setup, the first argument is props, and we don't need any past prop here, so we replace it with an underscore. It's a common practice for the cases where we don't need, for example, a first argument of a method, but in order to access the second argument, we still need to pass both. In such cases, underscore says, this is something we are not going to use here. Now, let's add vModel to every input field and submit event for the whole form. We'll use a prevent modifier to prevent a native form submit and call the addBook method instead. Optionally, we can use some CSS to make the form look nice. Now, let's modify our app.vue component to include addBook. First, let's import the addBook component and add it to the component's property. Also, we will need a new reactive property to define when we show the new book form and when we hide it. Finally, we can add the new component to the template. We will conditionally show this button only when the form is not visible. And we'll show this button when the form is visible. Now, let's try adding a new book. You should see the new book data in the console. Now that we've got these steps to work, we are ready to replace the logic inside the addBook method so that it actually calls a GraphQL mutation instead of just logging the new book to the console. Let's start with creating a new file in the GraphQL folder and copy-paste the mutation from the GraphQL playground to this file. Let's make a few tweaks here. First of all, we want to pass a new book as a variable here. When checking the GraphQL docs on the playground, we can see that the mutation expects a variable input. Let's add this variable to the mutation. And then we can replace all of this with the input variable. Also, we can reuse our book fragment we created earlier in the course to render book properties here. Now we can import this mutation to our addBook.view component. We also need to import useMutation from ViewApollo. Now we are ready to create a mutation. We need to pass our imported mutation as a first parameter to useMutation, and a second parameter we will pass as a callback, returning the variable's object. We need to pass an input variable, and in our case, it will be equal to the new book object. Now, we can alias mutate as addBook, remove the old placeholder addBook method, and omit the close form event in undone. Since we're using a number type input field for the rating, if the user doesn't fill out the rating in the form, we'll have to default it to null. Let's fill out the form and submit a new book. Let's check the Network tab to see if our GraphQL call is successful. Nice! We can see the mutation is being sent to the server and returns a successful response. Let's make a small modification to remove the requirement for at least 2 characters in the search term to show the full list of books. After commenting this line and refreshing the page, we should see 2 test book entries in the list. However, if we try to add a new book, we will see that the list is not automatically updating like it was with updating the rating. This happens because we are creating a new entity. And for our Apollo cache, it's a new ID, so there's nothing to update. We need to work with the cache manually to update the data, and this will trigger the page re-render. To update this data, we will need to read the query first from the cache with Apollo's readQuery method. Then we will modify the data, and we need to remember to always do this in an immutable way, with creating a new entity rather than mutating the cache itself. After the modification, we will write the new data back with writeQuery method. To access the cache and use these 2 methods, we will use the mutation's update hook. In the update callback, the first argument is a reference to our Apollo cache. We will access it and modify the data. The second argument is the response our mutation returns from the server. Let's start with reading the all books query from the cache. We need to import the query into the addBooks.view component. Finally, we'll show the source data in the console. Let's go to the browser and add a new book. Surprisingly, we will see null in the console. What did we miss? Usually, this will happen when the data shaping the cache does not match the query we are reading. For example, maybe the query has different fields or variables. We are sure it's the same query, but let's check the Apollo DevTools to see the variables. It looks like there is a search variable we need to add to read query. Let's pass the search term as a prompt from app.view to addbook.view. Now go back to the addBook component and define the search prop. This will be a type of string and it's required. Now that we need to use this prop, we have to change this underscore to props. Now we can add the search variable to the read query's arguments. After this, we can see the all books query as it's stored in the Apollo cache. Now we can remove this console log. Let's create a new data variable and combine the all books array with the newly added book from the response. This is important. We are not pushing the new book directly to the source data.allBooks because we need to respect the cache's immutability. If we try to do so, Apollo will throw us a warning. The last step is to write the new data back to the cache. We will need to pass the query we want to modify, correct variables, and a new data as data property. Now, whenever we add a book, we can see the list updated immediately. Sometimes we want to show the result of the mutation on the page, even before this mutation is resolved. To add an optimistic response to our mutation, we can use the optimistic response property in the mutations options right after update. So in order for it to work properly, this should be an object that matches an actual API response, including an underscore type name property for every nested object. The response type for the mutation is book. This is a GraphQL type we can find in our schema. We don't know what will be the ID, so we put a -1 as a placeholder here. And we spread the new book object to populate the book properties. Here, we have the same root property as the mutation response does, add book. Let's check out how it looks in the UI. We will click the Submit button to create a new book. I will pause the video here so that you can see what happens immediately after the Submit button was pressed. As you can see, the mutation is still not resolved. The form is still shown, but we already have a new book added to the list. In this lesson, we learned how to update Apollo cache manually when we are adding a new book to the list. This is very useful. If we want to build a real-time application, for example, a chat, it might be useful to have GraphQL subscriptions in our application. Subscriptions maintain an active connection to your GraphQL server, most commonly via WebSocket. This enables your server to push updates to the subscriptions result over time. In this lesson, we will learn how to handle subscriptions in your Vue application. Let's start with running a subscription in our GraphQL playground on localhost port 4000-GraphQL. First, as usual, we check the schema to learn how the subscription should look like. As we can see, we don't need any additional parameters to be passed, and the subscription will return us a new book. It's not clear from the playground, but this subscription will be triggered every single time a new book is added to the API. Now, let's create a subscription. We want the fields ID, title, author, year, and rating. Now we can run the subscription. There should be a loading spinner on the right side of the playground. Now, let's open one more tab in our playground and recreate a mutation to add a book there. Now, let's run the mutation and switch back to the subscription tab. This means that with the mutation changing data on the server, our subscription was triggered and returned us a new book. Before we start using a subscription, we need to make a few modifications to our client setup. Namely, we need to create an Apollo link for the WebSocket connection and then pass it to the client constructor. As a first step, let's install a subscriptions transport WS package. It will be required by Apollo as a missing peer dependency. Then, let's import WebSocket link from Apollo to our main.js file. We'll create a WebSocket link in here. First, we need a URI. As you can see, we use the same URL for the HTTP link, but a different protocol, WS, instead of the usual HTTP. The exact URL for any given case is usually defined on the server side. Now we have two links, WS link and HTTP link. We need to split our links to tell the client what link should be used in which case. Namely, for subscriptions, we are going to be using WS link, and for the rest of the operations, we want to use HTTP link. We'll first import split from Apollo, and then create a new link variable here using split. This will be a callback function that receives the query. And then we have to get the definition using the function getMainDefinition. We also have to import it up here. We have to return a Boolean value from this callback function. This will be true only if the definition kind is operation definition and the definition operation is subscription. Finally, we have to provide the two links that we are splitting. Now, we only need to replace the link option in the client constructor. We are ready to update our list in the View application whenever a new book is added to the server. Let's start with creating a new book.subscription.gql file and adding our subscription. Don't forget to utilize the power of fragments. Let's now import the subscription to the app.view file. Before using the subscription, let's start to think. What do we want to do when we receive an update from the server about a new book being added? We have a list of books, and most likely we want to update it by appending a new book there. As you remember, the list of books is a result of the GraphQL query, and when we want to update the result of the query with a subscription, we should use the subscribe to more option. We will start with exposing the subscribe to more hook in the useQuery call. It listens to the GraphQL subscription, and when we have a new result, it will update the current query with the result. We'll use a subscribe more function in here. It takes a callback function that returns an object, and we have to specify the subscription we're listening to. Document is the only required option, but we will still need to implement the logic for updating the query, and to do so, we need to utilize the update query option. This callback function will receive the previous result and the new result, and then we log it to the console. So far, we are not doing anything with the cache. We just want to see what we have in the previous result and what comes with the subscription. So let's go ahead and run the mutation on the playground. This is the same mutation we used previously. Now we go back to the browser. As we can see in the console, previous result contains the all books array, and new result has this structure. So what we need to do is, first, create a new result object with an all books property. This will contain the same books in previous result combined with the data from the new result. And finally, return it from update query. Now, if we add a new book in the playground, it will get updated on the page in real time. In this lesson, we learned how to react to the changes. Welcome back. As we saw in previous lessons, Apollo client caches the data fetched from the API and makes this data available across the application. Just like any global state manager, this means Apollo client is also capable of storing a local application state, even if it was not fed from the server. As you remember, everything on the GraphQL server is defined in the schema on the server. But what if we want to have some data available only on the client side? A good practice in this case is to define a local side schema and to let the Apollo client stitch the two together. Now let's try to add something to the list of favorites. Modifying the local data in the cache is not really different from modifying the data on the server. Both are done with the GraphQL mutations. For the server data, the mutation is defined on our GraphQL API. For the local mutations, we need to add the mutation first to a local schema. What is happening here? We define a few important things. First, add book to favorites. This is a mutation name. We can track it in the Apollo browser DevTools with this name, and we will use it later to write a resolver. We need to define the variable that the mutation will accept. We plan to add books from our main list to the list of favorites, and all books in our main list have a type of book. Finally, we want to return an array of books here. Now that we know how the mutation should look, welcome back. As we saw in previous lessons, Apollo client caches the data fetched from the API and makes this data available across the application. Just like any global state manager, this means Apollo client is also capable of storing a local application state, even if it was not fed from the server. As you remember, everything on the GraphQL server is defined in the schema on the server. But what if we want to have some data available only on the client side? A good practice in this case is to define a local side schema and to let the Apollo client stitch the two together. We can start by defining a local GraphQL schema. Let's create a file, typedefs.gql, in the GraphQL folder and add a new query there. We want to tell the Apollo client that we will have one more query in addition to those defined in GraphQL. This query will return to us the list of the user's favorite books. We also define the type of the returned array. It should be book because we plan to add books from the all books query to the list of favorites. Keep in mind that this step is entirely optional, but highly recommended. It will help you with the tooling such as auto-completing and validating queries in the IDE plugin, generating types if you are using TypeScript in your application, etc. Now, we need to pass the schema to Apollo client. Let's import it to the main.js file and pass it to the client options. To get data from the local cache with Apollo client, we do the same thing we do when retrieving data from the server. Use a GraphQL query. We will create our favorite books query here. As you can see, we reuse the same book fragment here to keep the data structure consistent across the application. As you remember from previous lessons, when we had a query, Apollo client will first check the local cache for data. If it's not there, it will send a request to the GraphQL server. With the local query, we don't want that second part to happen, and we will use the add client directive for this. When added to the GraphQL query, the add client directive makes Apollo client only search for the required data in the cache. Now let's use this new query in our app.view component. We will first import it, and then create a new query to retrieve a list of favorite books. Let's also use an alias for the result, and use console.log to see what data is in the result. This code will work, but in the console we'll see undefined. Why? Well, at the moment of the query, there are no favorite books in our Apollo cache, not even an empty array. To add them there, we need to add the initial state to the cache, just like we would define the initial state in Vuex. Remember, all the data stored in Apollo cache is structured as GraphQL queries. To add the initial data for our favorite books query, we need to write it down to the cache when we create an Apollo client instance. We can set the initial data for the cache using the write query method. We need to import the query up here. And now we can set the initial data. Let's start with an empty array. Now let's check the browser console when running our application. Our favorite book result on app.view now contains a favorite books and it's an empty array. Let's double check with Apollo DevTools. The favorite books are now a part of the Apollo cache. What if we wanted to have an initial value in our favorite books? First of all, we would need a book object to match the query structure. Let's check what fields book fragment contains. So our book should contain 3 of these fields. Let's go forward and add it to the right query call. We need a title, ID, and rating. We also need Apollo to recognize this object as a book type by using the type name property. Now we can see the initial book data in the console. Now, when we have a list of favorite books, let's render them within our application. First, we have to make the favorite book result available to the template. And then, we want this part of the template to have 2 columns. One for all available columns and another for favorite books. Also, we need to extend the style section. Now, our page should look like this. We'll render an actual list of the favorite books in the right column. Let's modify the template to iterate over our fabbooksresult.favoriteBooks array. Use the book ID as the key and render the book title. We should now see the list of favorite books rendered on the page. In the next lesson, we'll modify the local state in Apollo. Know how the mutation should look, we can create an add book to favorites.mutation.graphql file and write the mutation there. It will accept a book variable. Again, we use the add know how the mutation should. Now let's try to add something to the list of favorites. Modifying the local data in the cache is not really different from modifying the data on the server. Both are done with the GraphQL mutations. For the server data, the mutation is defined on our GraphQL API. For the local mutations, we need to add the mutation first to a local schema. What is happening here? We define a few important things. First, add book to favorites. This is a mutation name. We can track it in the Apollo browser DevTools with this name, and we will use it later to write a resolver. We need to define the variable that the mutation will accept. We plan to add books from our main list to the list of favorites, and all books in our main list have a type of book. Finally, we want to return an array of books here. Now that we know how the mutation should look, we can create an add book to favorites.mutation.graphql file and write the mutation there. It will accept a book variable. Again, we use the add client directive to tell our Apollo client not to send this mutation to the remote GraphQL server, but only operate on the cache level. We're reusing the book fragment again. Let's try to call this mutation from our application and check it in the DevTools. In the app.view, we need to add useMutation to our imports. We also have to import the new mutation file. At the end of the setup function, let's add a mutation. Let's use an alias for mutate, and then return it. Finally, we need to add the button to every book in the list to add it to the favorites. When we call the mutation, we are passing an object of variables. Our mutation requires one variable called book, and we pass a book from the books array when clicking a button. Let's go ahead and check how it looks in our application interface. Awesome, the mutation is called correctly. As we can see from the DevTools, the only problem is that it does not update the favorites book list. Such instructions are called resolvers, and they should be written as an object with the fields like query and mutation. We didn't need a resolver for our favorite books query because it was a straightforward cache reading operation. Our new mutation is more complicated and therefore requires a resolver. Let's go ahead and open our main.js file and start with creating a new constant called resolvers. Now we need a mutation field. In here, we need a nested field named exactly like how we name the query of the mutation, and then we'll set it to a callback. So far, it's just an empty callback. It accepts 3 arguments. Parent. We won't need this in our resolver, so we'll replace it with an underscore. The variables that are passed to the mutation when it's called, and a context. Cache is one of the context properties, and we will need it to read and write the correct query. Our mutation should modify favorite books array in the cache. So let's retrieve this array, reading the favorites books query first. Now we need to create a new object where favorite books contains the previous list and the new book. Finally, we need to write this new data back to the cache and return an array of books. Awesome. The last step we need to take is passing resolvers to Apollo client constructor. Now we can see that the mutation is adding the book to the list of favorites. Great job following along. We've successfully learned how to use Apollo client cache as a replacement for your global state and how to work with reading and writing data to it.